Okay, I am finishing up, or there are some questions that sometimes students have about some different concepts about polynomials. And these are some true and false questions that some students come across that we're going to discuss about polynomials. Polynomials. So this is kind of a question and answer session right here. The first question is a fifth degree, okay, so a fifth degree polynomial. All right, polynomial can have 5 turning points. So 5 turning points in its graph. Now, when you read this problem, the key thing is, what is a turning point? Well, a turning point is where a function changes from increasing to decreasing or decreasing to increasing. It's basically a max or min. When you talk about a fifth degree polynomial, it can have 5 turning points in its graph. What would that mean? Well, if I have a turning point, that would be, we got like this, we go, all right, 1, 2, 3, 4, 5. All right, so changes 1, all right, I can have 5 turning points in this graph. So 1, 2, 3, 4, oops, and 5. All right, so fifth degree. All right, and then I just made it like that in just an example. Well, if you have a fifth degree with 5 turning points, let's count how many zeros it would have. 1, 2, 3, 4, 5, 6. Has 6. So a fifth degree, all right, polynomial, can it have 5 turning points? The answer is, well, I think no. All right, no. All right, that is false. What could have 5 turning points? Well, if we have 5 max or mins, all right, going 1, 2, 3, 4, and 5, it would have to be at least, okay, at least a 6th degree polynomial. No, it would have to be at least a 6th degree polynomial. 6th degree polynomial. All right? Because you would have to have 6 zeros or complex zeros in order to identify this. Okay. Another question that students usually sometimes have, okay, is it possible for a 6th degree polynomial to have only 1 0? Can a 6th degree, let's just talk about 6th degree, can a 6th degree poly have only 1 0? All right. Well, the answer is, well, can it? Well, let's think about it. If it's 6th degree, that means only 1 0, that it would have to go up and then keep on going up. Well, if it's 6th degree, that means it's an even polynomial, all right, an even degree polynomial, which makes it that its, I guess, values would have to be, if it had a negative leading coefficient, all right, both values would fall both sides. If we flip this around and create it like so, oops. All right, I don't even know what I'm doing here. Rest of my graph. If I switched it around and create a positive one, where I go like this and come up, all right, like that, or a 6th degree of some sort, and I try to move it down, it would always have to have at least 2. So the answer in this one is, once again, no, or false, okay, because it would have to have at least 2. Must have at least 2 zeros if it's a 6th degree. Or any even degree would have to have at least 2 zeros, okay, or none, because you could bring this up all the way to the top, all right, where it have no zeros, okay, if it was shifted. All right, another question, or true and false statement that students sometimes have trouble on, is a graph of a 3rd degree polynomial must fall to the left and rise to the right. All right, a 3rd degree polynomial must fall to the left and rise to the right. All right, well, a 3rd degree must fall to the left and rise to the right. Well, when you think about this, a third degree polynomial, if we just sketch it out, third degrees do rise to the right and can fall to the left. However, that is when you have a leading coefficient, I'll call it LC, which is positive, correct? If we had a LC of a third degree which was negative, what would happen is that this would go and turn around. Oops, not turn around, but actually flip. And I'll flip this. All right, and we go in the opposite direction if it was negative. So I guess the answer to this problem is no, not true. All right, no or false. And the reason why is because you have a leading coefficient which is negative, you would have the opposite effect on this graph as a reflection over the x-axis. Okay. And one final statement, all right, that we want to see, all right, is if a function has a repeated zero of even multiplicity. Okay? So if a function has a repeated zero of even multiplicity, all right, then the graph of the function only touches the x-axis at the point, but does not cross it. All right, cross x-axis at the point. All right, only touches the point, but does not cross it. But does not cross. Does not cross x-axis. Okay, at that point. So if a function has a repeated zero of even multiplicity, the graph of the function only touches and doesn't pass through, all right, that point. Well, that one I think, if you looked at my other tutorials, that one is definitely going to be true, all right, because if you have an even multiplicity here at a 0, whenever you hit it, if it juts back down, it's tangent, all right, so that one definitely is true. All right, so going through several different problems and statements dealing with polynomials. Hope this helped you out. If you have any other questions, check out some other tutorials by me or others, and hopefully we can give you some answers. All right, good luck and God bless.